Hey guys, I'm here back with another math video. Daniel's been gone for MOP, which is a math summer camp you advance to after you pass USAMO or JMO or whatever. So he's busy doing a crap ton of math, and so he hasn't been able to do some videos recently. So I'm still here, and without further ado, let's do this AMC 12 problem. Pause the video if you need to, and without further ado, here's the solution. So, looking at this problem, suppose the products of the solutions of x is the smallest possible integer, what's n plus n? You see that the equation is really messy, with like different bases and stuff, and you can't really manipulate logs with different bases. So let's see if we can make that equation quote-unquote friendlier. So keep in mind that one rule of logarithms is that log base a x is equal to log x over log a. So keeping that in mind, we can actually convert all of these log base nx and log base mx into that form. So this equation then becomes 8 times log x over log n times log x over log n m minus 7 log x over log n minus 6 log x over log m minus 2013 equals 0. Let's simplify it down further. You get 8 over log n log m times log x squared minus 7 oh sorry, made a mistake. My tablet is still laggy, so I gotta go a bit slowly. Minus 7 over log n plus 6 over log m log x minus 2013 equals 0. Looking at this equation, if you look closely, you'll see that it sort of resembles a quadratic equation, doesn't it? And, well, that's interesting. Like, what if we try, now the question asks for the product of the solutions for x of the equation. And we know that in the quadratic equation, the product of the solutions is usually this term. But we have to be careful here, because this term doesn't give this term does not equal, let's say these are the possible roots. This term does not equal x1 times x2. Rather, it equals log x1 times log x2. Because remember, this quadratic solves for log x, not x itself. So if we just take this term from the quadratic equation, we get this quantity, but we want this quantity, the product of the possible values of x. So how do we get that quantity? Well, we should keep in mind that while this quantity may not be useful, this quantity plus log x2 is useful, because this is equal to log x1, x2. And if we know log x1, x2, we can then find x1 and x2. Remember, the addition of logs, this is just a formula. So if you add two logs together with the same base, you get the log of the product of those things in the logs. So we should find the sum of the roots of this equation, since this equation solves for log x. And the sum, based on Vietta's formula, if you know ax squared plus bx plus c, well, the roots, sum of roots equals negative b over a. So by Vietta's, that means that log x1 plus log x2, consider if these are the solutions, is equal to 7 over log n plus 6 over log m divided by 8 over log n log m, which simplifies to 7 times log m plus 6 log n over 8. which further simplifies to, now keep in mind, if we add these, this is actually equal to log m to the 7. This is equal to log m to n to the 6. Because if there's a coefficient of the log, you can shift this over to make it the power of what's inside the log. And when you add those together, you get log m sorry, my phone is going off. Just, you guys are more important. M to the 7 n to the 6 divided by 8. And remember, the coefficient of this log can be made into the power, so this equals m7 and 6 root 8. Well, log of that. Where does this bring us? Well, remember that this equals that, right? So this would also equal log x1, x2. And since we can just cancel out these logs, we get m7 and 6 root 8 equals x1, x2. That seems much simpler in my opinion. Now, we know that m is greater than 1 and n is greater than 1, right? And we also know that, let's see, we also know that this is an integer. So we want to minimize this, and really this just takes some guess and check. It's not too bad considering there's only so many numbers. There's only so many numbers that, you know, are root 8. And after some guess and check, you eventually get that m equals 2 squared and n equals 2 to the 3. And that gives you 2 times, so that gives you 2 to the 14th times 2 to the 18th, which is 2 to the 32, which if you divide that by 8 equals 2 to the 4. Seems to work out. So this is 4, this is 8, and the question asks for m plus n. So 4 plus 8, the hardest part of this question is adding them up. It's 12. That's the answer, and thus the answer seems to be A. Alright, see you next week. I don't know, it's true. By induction. We're not actually done yet. We proved that it's always true, but we also have to prove that neither of them is divisible by 3. We can't miss that. So let's try prove neither of them is divisible by 3. Let's use mod. So x1 is equal to -1, right? -1, so -1 mod